I'm CK. Tonight we're going to build another eurorack module from Befaco, and in the spirit of you can never have too many VCOs, we're going to build their EvenVCO. This is version 3 of the product. Feels kind of hefty. Hope you enjoy the video. Here's the bag from Befaco out of Barcelona. As usual, I can't get a simple Ziploc bag open. Let's grab the paperwork, and what I expect is the circuit board and front panel out first. And of course, Befaco stickers. I've already got these. These are dupes, in case anybody wants to trade. Let's see what we got. Ooh. Leave that aside for a second. And it's the typical Befaco instruction set. Not too detailed. They pretty much just list the parts, and every now and again they'll make a particular statement about a challenge with a board, but not very often. The only thing about the Befaco, and of course, oh, look at this. They have a flow chart. That's not, I haven't seen that in a Befaco module before. So we'll read through that. And then there's the front panel layout. This is often useful because they crowd a lot of stuff on their circuit boards, and it is on occasion hard to read the silk screen for a particular component, so having this is very handy. Now, the good stuff, circuit board and the front panel. Here's the panel. Let's see what's interesting here. Got an octave switch. I don't know whether there will be a switch with a stop or a potentiometer. Tuning knob, volts per octave in, I'm not sure what that's going to be, modulation, sync, pulse width. So we've got a saw wave, a sine wave, triangle wave, sine wave, saw wave, and square wave. And I think that's the output. Now let's look at the board. We've got a couple of surface mount components already installed, and one on that board that's already installed with a chain of resistors around it. I'll look this one up when I get a chance, if I can read the number. But the board looks typical, good quality Befaco board. All the holes are through-hole plated. The values of the components are not on the board, but they don't generally do that, so I'm not surprised by that. This is the controls and pots board. Oh, that's interesting. This is EvenVCO version 3.0.3.3. This PCB is on the public domain. I did not know that. So this may be something that I'm just straight not familiar with, but that's nice that you can play with this board and adjust components, maybe change some things around. That'd be kind of fun. So we've got the octave, yeah, so those are all jacks and those are all jacks. So that's that for the board and the circuit board. Now, let me get some parts bins available. Oh, I only have one parts bin. Oh, magic, I've got two. Whole bunch of resistors. Bag A is all resistors, and I can see there's a ferrite coil, ferrite core, ferrite bead, and some diodes in there too. Power cable, Bag B is capacitors. I almost said condensers because I'm really old. Condensers, transistors, and voltage regulators probably, and some electrolytic caps and some trimmers. All, and the power cable connector and headers to connect the two boards. See what's in here? Ah, yeah, this is a big old rotary switch. Look at this guy. Get my pair of pliers here. Click, 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 click. This would have worked on a band selector in a shortwave radio from 1935. I'm surprised they were able to source a big old switch like that. I like it. And then, of course, some normal potentiometers. Jacks, and a big old knob, which will go on that multi-selector. ICs, and as usual, a Befaco panel nut driver, which is nice that they include this. However, I'm counting in my head, I've made 6 Befaco modules now, and I have 6 of these. I don't need 6 of these. I don't know what to do with the extra ones. Maybe I'll run a contest. So that's the board and the parts. Looks interesting. I'll get the soldering iron heated up and we'll start putting this thing together. Resistor time is going to go on for some time today. Ferrite bead, which means we have to keep at least one. Actually, we have to do 2. We have to keep 2 leads. Don't jump off the table, resistor. Let me go get that. We have to keep one resistor lead for the ferrite bead, and we have to keep one resistor lead for a resistor location on the board that is no longer used. So we'll be jumping it with a resistor lead. Well, I got them a little bit sorted, but then I got bored. So I'm going to go ahead and put all the resistors on, and as usual, for resistor time, we speed up the playback, cut out parts of it, and I play some other music while I listen to classical WQXR out of New York City on their iPad app. So enjoy watching resistor time. That was resistor time. All done, lots of resistors. One, except for one. There's one resistor I have not put on the board yet. It goes up here in R3, but it's, as you can see, it's not the same size. This has to be a stand-up resistor, and I don't want to put that in until I'm done with the diodes and the ferrite beads for reasons, because I don't want to lean it over that way with the ferrites. So I'm keeping that one aside. Now, one thing I do want to mention, this is probably the biggest pain of when you're soldering or putting something together, is when you get all these singleton resistors, you know, 21 type. I don't go in order. I don't find that useful, because then you're scanning through the parts tray trying to find that one resistor. What I do is I just go grab a resistor, get the value, find the value, put put it in the board, check it off. Don't try and go in order if that's too much of a pain for you or too annoying for you as it is for me. Just grab a resistor, find its value, find where it goes, and put it on the board. Pretty straightforward. Now we're going to do the diodes and the ferrite beads. So first we've got the 4148s. And as always, polarity matters. Little black stripes got to go to the little symbol on the board. Let's see, so, oh, I got the board upside down. D1 goes up here, and you can barely see it. That's another, Befaco really crams a lot of components into a board, so they suffer a little bit from a lack of clarity. Again, there are some numbers that you can't read, and here you can just pretty much make out the line where the cathode goes, but it's not really as distinctive as on other boards. They might, you know, far be it from me to tell them how to lay out their board, but they may want to consider having their software do like they do here and just put the full diode symbol, so there's a stripe and the diode symbol, so that would stand out in a smaller location like this. But I don't know what constraints they're working with in their software or design flow. The other thing I do want to point out, and I'll use this board as an example, because it's, in my experience, it's really unique to Befaco. Let me get this focused in here. If you look at these circuit board traces, look at this one, from this pin to this resistor. It's not straight, it swoops, it's a curve. This is not straight, it's got a little jog in it. This trace has a little jog in it. Their software, this one, it meanders around, it goes, it's like a river, going all the way down here. There are no hard edges on their traces on the board. Look at that little hump there. I don't know why, and it's not a bad thing, of course. I just have no idea why their board software lays out traces like that again. Now I'm going to skip again. I'm going to put the ferrite cores on, ferrite beads on this board, then go back and do these two diodes on this other board, as well as R3. So as I was clipping my resistor leads, I picked two very likely candidates to be ferrite bead leads. So we put them through the ferrite bead, and we find on the board they don't use a symbol, they spell out the word ferrite. Oh, there was one other, there's an R15, R115. On this board that's no longer used, so you save a resistor leg and just bridge it across. And now I'm looking over all my solder joints to make sure there's nothing amiss, and touch up any that look like they might be a little bit cold. Those all look good, and those all look good. Okay, so we're done with our first bag of parts. Now we're going to put the sockets on the boards. IC sockets on the boards. It's in the foamy bag. And they're all 8-pin. So we'll just find the ICs and make sure we have the notches going the right way. And the way I do small ICs like this is I rest the board on my hand. My pinky finger is supporting the socket, and I do 1 pin. And I lift the board up. And as you can see, the socket is a little cattywampus, which I expected. So I heat that one leg of solder again and just push firmly, and that gets the socket flat on the board. No muss, no fuss. And then I can go back later and do the rest of the legs. This is just to make sure they get on the board flat and firm. Okay, I'm not gonna speed this up right this second, because this socket, as you can see, it's on top of this surface mount part, which is already installed, and it doesn't go flat. The surface mount component is too wide to fit between. It won't fit in this gap. So I have two choices. One choice is to expand that gap a little bit. The other choice is to mount this so it's not flat against the board. I'm gonna get my Dremel tool out and I'm gonna grind away the inside of this socket a little bit. So I'm going to do that off camera. It took about 15 seconds to do. It was longer to get the Dremel tool out of the cabinet and plug it in. Now it sits flat on the board. Okay, that's all the sockets, I think. That's something I always like to double check. I've gone through a board and then got to the end and I'd forgotten to solder all the pins on one of the sockets. Things like that can happen. And then we've got a whole bunch of capacitors. Yep. So the first capacitor, C22, is redundant and no longer needed. I've sorted the caps all out so you don't have to watch me fiddle around with them. And now we'll put them all on the board. Again, these, except for these trimmers, these are pretty straightforward, so I'll be doing fast replay on this. The problem with these trimmers is a lot of the legs were bent in shipping, so you'll see me using my needle nose to fix those up. Otherwise, I'll just be putting all the caps on. The other thing about the caps is there were a number of them whose leads were very, very close to other leads. So on the back of the board, make sure I get the polarity right here. On the back of the board, particularly in this area, there's a lot of really tight spacing for your solder points, so just make sure you keep an eye out on not bridging two contacts. Oh, and the other thing is C15 is here. You can barely read the silk screening, so you may want to go to the back of the book if you want to look at that. The other thing is the ferrite bead, the diode, and C15, capacitor 15, are all touching. There's there's no space between those. Now we're going to do the transistors, even though first I just noticed that I fouled one of the holes for a pin header while I was soldering. This hole is a little fouled, so I'm going to heat this solder up and suck the hole clean of solder. This solder sucker is the best I've used, and I've tried a whole bunch of them. I don't know where I bought it from, so I can't buy more, and I can't tell you where to get it. So there you go. Now we've got voltage regulators, or transistors. We'll do the 39 of, oh, the other thing is on this cap here, C7, the 2.2 nanofarad, C7 WINMA. I don't know what WINMA means. It's got it in parentheses right there. I don't know what WINMA means. So now we'll do the transistors, and again, they're not all that interesting. Transistors are on. Now time for the trimmers, and as the guide author points out, double check the values. So there are 3 10Ks, which are 103s, and 1 1K. So you want to make sure you get those correct. And this has got a somewhat bent pin that I bent too far the other way. Trimmers go on this side of the board, but the identification is on the other side of the board, just to make it a little confusing for you. And which way you put them on, there's a little graphic depiction of the screw that's sticking out of them on the silk screen. It's width, and now we've got init, and init is somewhere. Maybe it's on this board. I think it's on this board. Yep, it's on this board. And let's see what's next. Next will be the female pin headers. And they will go at TO main and TO main A and TO main B. And same thing as with sockets. The pin header, actually I'm just going to set it down like this. Support the pin header a little bit, tack one leg, and as you can see, I'm clearly way off here. It's crooked, it's all kinds of things. Actually, it's less bad than I thought. But still, it doesn't matter, because you're going to press it firmly with your finger while you reheat that solder, and it settles right in. Now the fun part, all the panel components. And there aren't too many. Okay, first we're going to put some spacers on the board. I'm going to double check this spacing. Yeah, that looks good. Oh, and by the way, I still have not put the ICs in. I know that. Hold on. When did we put the power? Oh, we didn't put the power connector on. I missed the power connector step. Sorry, guys. So the power connector goes here, which is an interesting location because it's going to come out here, of course. Now we're going to put all the mini jacks on the board. And as usual, we're not soldering anything yet. jacks. And then we'll put all the pots, 2 main pots. Now we put the rotary switch on, and he's got a couple of trim this, trim that's. I think that the locator pin here needs to get trimmed off. One side would also cut the long center leg. Yeah, okay. So that's not the locating lug. Oh, he means this one. Okay, never mind. So you got to cut off this lug, which would lock into a hole on a panel, but we're not going to be locked into a hole on a panel. I'm not going to use my regular side cutting pliers or my flush cutters for this, because I don't want to damage the jaws. I have 1 pair of carbide tip cutting pliers. Carbide tip means they're very strong, and cutting through most metal won't harm the jaws at all, and it just cuts it right off, and there's no harm to the jaws. I recommend getting a pair of these. They are pricey. They'll be more expensive than other pliers you've bought, but they'll also last you a lifetime. So it's one of those cases where if you buy it once, if you take the pain once, you will benefit for a very long time. Let's get these pins in here. There. That went flat. So that's interesting. So that's much higher. That's much higher than any other component on the board. Wow, this will be interesting to see how this sits. I'm gonna put the front panel on here and see how this all lines up. It's almost as if the jacks don't have much thread room to play with, but let me see how it looks. Oh no, that's not too bad. No, it's not great. No, it's not great at all. No, in fact, this kind of stinks. So with this rotary switch, controls the height, obviously. It's the tallest thing in this circuit, but as you can see, with it at its full height, the jacks don't have any threads sticking out above the panel, nor do the potentiometers. I mean, I can pull them up with the panel nuts, but then you have to balance that with the fact that you've just pulled it out of the circuit board holes. Well, this is kind of stinky. I'm not pleased with this. Let me see if I can get this octave selector down on the board a little more, no, it's all the way down. I mean, I can get more threads if I flex the panel down a little bit, but then it's not parallel, and no way can I get any threads on the pots. So I'm going to do something I normally don't like to do, and that's have the front panel not completely parallel to the circuit board, which is weird to me and uncomfortable, but it's the only way I'm going to get some threads on these on the jack screws. So what I'm going to do first, I'm going to solder one of the legs on the rotary switch. When you do this, be very careful, because you've got these surface mount resistors in a ring around that, and you can bridge to them, or you can get your soldering iron too close and accidentally bang into it and potentially loosen it. So just be very careful around when you're waving your big old 70-watt soldering iron around those surface mount components. So I'm going to tack this. Actually, I'm going to do a couple of pins on this jack to give me a bunch of strength here. Oop, hold on a second. One of my perimeter lights just went off. I have to see. Now, one of my perimeter security lights went on, and I had to go and see what was happening out there. Some critter set it off. No worries. So I've got that jack pretty much solidly in place. We do get almost 2 threads showing on the jacks, but there's not enough to really give you a good grip. So again, I'm going to be very rude here in my opinion and just kind of torque bend the board down. So we'll have lots of threads here, enough threads here to give me a little bit of security. I wish it wasn't like that. The pots have I will get no threads on the pots, because I can't even pull them up enough. Because if I pull them up enough to get some threads, I'm sorry, I'm talking a lot about this, but it's bothering me. And again, it's unusual to me for a Befaco kit. They're usually very, very mechanically good. But back to fast motion as I solder all these connections in. Okay, with all the jacks soldered, I am going to do a little compromise with the pots. So what I'm doing here is I'm putting a panel nut on just a little bit, not a lot, and watching here. Focus down or zoom down a little bit more. So I'm having the pot not resting on the circuit board in there, and also not flat up against the panel, because if it's flat up against the panel, well, I may be able to, you can see I've got a little bit of the connections still coming through the PCB, but I'm going to go screw this about 3 turns down, then push it down again so I can get enough security on my solder joints to not be too concerned about lack of conductivity or potential wear over the years that I use this. You notice there are no LEDs on this. That's interesting, isn't it? Now, before we mate the parts, I'm obviously going to put the ICs in. And I'm going to have to go to the diagram in the back for that, because I can't see the silkscreen anymore. Now we're going to do 3 TL72s, op amps. Now, the final thing for me when I build something like this, we're getting ready to mate and finish everything up. First thing I want to do is I take a piece of paper and I look at every solder joint. Like that solder joint exists and it's probably okay, but it's not great. So I'm just going to touch it up. And look at every solder joint for good joints, for shorting or grounding, and also, did you miss one? Because on a dense packed board like this in particular, it can be very easy to miss one. But we didn't, so we're all good. So I'm going to mate the boards at this point. So we get the pin headers lined up. Give it a nice little squish, squish. Now we've got screws to go into the spacers. And hold everything securely together. All done. Here's the front. Octave, tune, pulse width, outputs, inputs. Now one thing you'll notice on the octave, this knob is not real great, or the silkscreen isn't great, or something isn't great, so I'm about here inside the 32-foot octave, and then I go here and I'm almost on the line, but then I go around all the way up and I've moved back again, so you just have to look at that very closely. So front, side, back or bottom, other side, top, and bottom. Next, we've got a little bit of calibration to do. Calibration time. And first, let me plug it in. I haven't plugged it in yet. We're using a little frequency central Routemaster that I've got lying around. And there are no LEDs on here, so as I mentioned, so we won't have a real good indicator of power up. I mean, one indicator, of course, is smoke, and I don't see any smoke, so that's a good sign. Now the first test is to set the reference voltage, the ref trimmer. So the ref trimmer is over here, and what we want to do is we want to go to test point 1, which is right here, and we should be getting, making sure the meter's in frame, yeah, it is, should be getting 1.5 volts there, so I will use the ground pin. Well, that's not getting me anything I want. So let me try this again. Oh no, that's perfect. I'm sorry. It says 1.5 volts. So that's what I want, 1.578. Now, the question is, should we adjust that 0.78 out? Well, I'm going to go ahead and give it a try, just to see if it's a big deal or a little deal. Okay, so that's 0.18. Might have been 0.18 to begin with, because I'm looking at it at an angle so y'all can see it on the camera. I'm getting some extra segments. Okay, I think I can get this down to 1.5. Of course, when you're doing this, you don't necessarily want to be like me and just be like grabbing the PCB when it's powered up. But I don't care about things like that much. You should, I would recommend. So let me tweak this just a little bit more. And as you can see, test point 1 is on the control board. And I'm using one of the ground pins from the eurorack power connector to get my ground reference. 1.499, oh come on, we can get it to 1.5 even, can't we? And that's 1.5 1.01. Good enough. I mean 1.501. Okay, the rest of the calibration we'll do in the rack, because it's really about audio at this point. We're following the flow chart. So now we're going to go to 1 foot on the rotary switch, which we're at. And I'm going to tune the sound up with the tune pot in the middle. And then we'll adjust int to C5. Sorry, I'm looking for my tuner app on my iPhone. There it is. Okay, so that's coming in at B4. So I want to go to init, which is here. Let me turn it up a little bit and set my So that's a good solid C5. And now we'll go to 8 foot and see where we are in terms of tuning. We're actually at B1 where we should be at C2. So we're going to adjust width to get us there. And width, I believe, is on the top here. Which one is width? So width is over here. Turn it up again. Now that's a solid C2. Now I'm going to go back to 1 foot and see what that's tuned to. And now that's looking perfect. So just by adjusting tune, I was able to get to C5, and now I seem to be good across the whole range. Let me double check. I'm going to bring the iPhone into the screen so you can see this, so you know I ain't lying to you, even though you can hear it pretty well. So as you can see, that's 5 octaves of very good, dead stable tune. So the width is right, the initial frequency setup is right. Now I'm going to turn things off and reconfigure to do a more general look at this. Okay, so we've got it hooked up in our regular rig with MIDI keyboard feeding a Befaco Midi Thing feeding a frequency central envelope VCA, and then going to my little pile amp that I have out here to test stuff. So we're coming out the even port, and I've got the scope set up on the saw wave. So quiet that down a little bit. Let me change pipe length, octave. Okay, now let's see what it sounds like on other frequencies. So I'm going to take the scope and put the scope in the saw wave, and take our even output and put that in the triangle wave. Now we'll try it over here in the sine wave. Let's go into the square wave. I'm going to move the scope over to the oscilloscope, to the sine wave. Now, you know, I don't know if you're noticing this, but the waveforms sure aren't normal. I know if you looked at the first one, the triangle wave, it had a little break at the tailing edge. So does this. It breaks. There's a break at the low end, at the bottom of the cycle. Let's see if I can. Yeah, that's just kind of weird. I don't know what it could be. Let me change pulse width here. So it sounds about as you'd expect. So what I'm going to do right now is I'm going to switch over to using the Division 6 sequencer to drive it. Let's see what that sounds like. Let's see how responsive it is by speeding it up quite a bit. So it sounds fine. It's got lots of nice options for picking out which wave you want. The only thing, again, that's intriguing, and let me go back to the saw wave, is on the scope traces you can see again, as it trails off, it just goes flat. I'm not sure. Maybe that's because I've got the envelope set wrong. I'm changing the envelope a little bit, but I don't think so. No, that's the pure wave. That's not being influenced by the envelope. Of course, it wouldn't be. That's not affecting this at all. But just look at that little kind of drop-off. Interesting. It doesn't seem to affect the sonic quality. So that's it. That's the Befaco EvenVCO. It's a good little sounding VCO. Nothing too out of the ordinary about it. It's a plain vanilla sonically. But it'll be useful to have that much range in a VCO, easily selectable, and have 5 good outputs for different waves you may want to use. And we'll go back to the middle. Oh, I'm hooked up to the sequencer. Which is even, middle of the road. Hope you enjoyed the video.